Okay, today's lesson we're going to continue with the unit circle, and we're going to look at the specific trig ratios that show up with angles that are on the unit circle. So you can see in the diagram here we have an angle of pi by 3, or 60 degrees, and we saw from a 60 degree angle triangle, when we did the unit circle, we had a x component, or horizontal, of 1/2, and a y component of root 3 over 2. So we can see that when that coordinate is drawn on the unit circle, the x coordinate is the x length, and the y coordinate is your opposite or your vertical length. So we can use basic trig ratios. So all we basically have to do is look at the triangles. We want to draw our special triangles. Let me re-sketch that here again. So for a 60 degree or pi by 3 triangle, we have 1/2 as our cos, root 3 over 2 is our opposite or our sine, and 1 is our hypotenuse. So if we just use basically regular SOHCAHTOA, we can see for sine it's opposite over hypotenuse, that's root 3 over 2 divided by 1. So we just get root 3 over 2, which is that y coordinate. And for cosine we get 1/2 over 1. And for tangent, it's opposite over adjacent, so we have root 3 over 2 divided by 1/2, so we can simplify that a little bit. The 2's would cancel, so we get root 3 over 1, or just root 3. So the tangent, you got to do a little bit of a calculation, but the rest are pretty easy to do. So that means whatever the coordinate is, so for that one that we just had, we had root 3 over 2, I had 1/2 root 3 over 2. So we saw that our y is our sine, so root 3 over 2 is our sine, our cosine is the x-coordinate, so 1/2, and tan we divide them, so we got our root 3. So if let's do the same thing again for our 30 degree angle triangle, or pi by 6, so pi by 6 is 30, we get 1/2 as our opposite, root 3 over 2 and 1, so you can see we get the exact same ratios, just sort of flipped around a little bit. So our sine is our y this time, which is 1/2, cosine is our adjacent, root 3 over 2, and then tangent would be opposite over adjacent, so 1/2 divided by root 3 over 2, and the 2's cancel again, so we get 1 divided by root 3 this case. So regular, sine, cos, tan, those are our basic trig functions, but we also do reciprocal trig functions as well. So the reciprocals are cosecant, and we use the notation CSC. And what that means is we're doing the 1 over sine. So in terms of a coordinate, it would just be 1 over the y. So when we did sine of 30, we got 1/2. So that means the cosecant of 30 is going to be 2 over 1. Just do the reciprocal of it. And that works the same for all of them. So we basically just need to remember that secant is 1 over cos, and cotan is 1 over tan. So as long as you remember those, all you have to do is do the reciprocal of whatever the coordinate is. So one other thing to remember is the cast rule. So remember the cast rule in Math 20 we labeled the quadrants like that. So that meant in quadrant 1 all things are positive, in quadrant 2 just the sine is positive, in quadrant 3 just the tan is negative, and in quadrant 4 just the cosine is negative, or positive, sorry. So that also applies to our new ones. So we still have all in the first quadrant. We'd have cosecant as well for quadrant 2, cotan as well for quadrant 3, and secant for quadrant 4. Because they're tied to sine, cos, and tan, the same positive and negatives work for those too. So what we want to do now is, now that we have a certain coordinate, we want to figure out what are the trig ratios. So the easiest way to do this is just use our coordinates. So we know that our sine of that angle A is just going to be our y coordinate, so that's 5 over 13. We know our cosine is going to be the x coordinate, so negative 12 over 13. And our tangent will be opposite over adjacent, or y over x, which would be 5 over 13 divided by negative 12 over 13. So we can simplify that to be negative 5/12, because the 13's would cancel. So now, once we have those, the other ones are pretty easy. So cosecant is the opposite of sine, so that would be 13 over 5. Secant is the opposite of cosine, so that would be negative 13 over 12. and cotan is opposite of 10, so that would be negative 12 over 5. Okay, so that means if we were to look at our point in the quadrant, so let's kind of plot that. So negative 12/13 would be that way, and 5/13 something like that. So we've got our angle somewhere over there. So we know that this, in terms of quadrants, is in our sine quadrant. So that means our sine should be positive, which it is. And then correspondingly our cosecant would be positive, which it is. And the rest are negative, which they are as well. So that does match our cast rule. Okay, so now in this case we want to figure out some exact values. So if they ask for cotan of 0.5, we can't do cotan, it's not a function on your calculator, so what we have to do is convert it to our regular one first. So what we would do is go tan of negative 0.5, and these are in radians. If there's no degrees listed, remember it's radians. So we would go tangent of negative 0.5, and then what we want to do is flip that answer. So tan of negative 0.5, we get an answer of approximately negative 0.5463. So that's our answer for tangent. So now all we have to do is figure out the cotan. So then cotan of negative 0.5 will just be the reciprocal of that answer. So all we do is go in 1 divided by, and that gives us an answer of negative 1.83. So that's what our cotan ratio is. So it's not an exact value, but you get the idea of, we just basically need to do it as a tangent and then flip it. So 1.83, negative 1.83, we know that it's in, if it's a negative tangent, that's got to be in the C or S quadrants. We don't know which quadrant exactly, but it's got to be one of those. And that just means our x divided by the y would be 1.83. So it could be something like 40 degrees or somewhere in there. Okay, so let's do another one where we want to do the exact values. So cosecant of 5 pi by 4. So we know that, actually let's go back to last one. We know the angle was negative a half radians. So that had to be, half a radian would be somewhere in this quadrant. So we know it's in quadrant 4. So that's if we were trying to figure out that. Anyway, let's go to this one. So we got 5 pi by 4. So we know that that is equal to 225 degrees. It's 5 pi by 4. So if you forget, remember, go 5 over 4 times 180. That'll give us 225. So we know it's in that quadrant, and we're looking for cosecant, which we don't know, but we can use the ratio for sine. So for a 45-degree triangle, remember, sine is 1 over root 2. So if we know that sine 5 pi by 4, and based on that quadrant, we're in the t quadrant, so we know it's going to be negative, because we're going to be going downwards, so we know it's negative 1 over root 2. So then all we have to do is do the flip to get the cosecant. So the cosecant of 5 pi by 4 will be negative root 2 over 1, or just negative root 2. And that's it for that one. So let's do a couple more, but in reverse. So in this case, they're telling us that the secant of the angle is root 2. So what we want to do then is convert that first to cosine. So secant to cosine, remember, is reciprocal. So that'll be 1 over root 2. Now what angle is 1 over root 2? Well, that's still our 45 that we just did. So we know the angle has to be 45 degrees, or pi by 4. So now all we have to do is meet the condition. So we want to figure out where is cosine going to be positive. So we know that that's going to be in quadrant 1, which is our 45 degrees, and in quadrant 2, or 4, which would be 315. So we want to do that for all locations if we make 2 complete revolutions. So let's write it out in degrees first. So we know it's 45 degrees. The next one will be 315. Then we'll have 360 plus 45, which would be 405. And then once again, 720 minus 45 is 675. So there's our 4 locations in 2 complete revolutions. But because it was given to us in radians, let's keep our answer in radians. So we should have pi by 4, 7 pi by 4, and 9 pi by 4 is the next one, and our last one would be 8, 16, 15 pi by 4, I think is correct. So once again, if you can't remember go 675 divided by 180 and just reduce that as a fraction, and we get 15 over 4. So that's correct. So we have 1, 7, 9, and 15 pi by 4 as our 4 correct values. Okay, so let's do one more. So this last one is cosecant. So remember, that's attached to sine. So we want to do 1 over. So in your calculator, go 1 divided by negative 1.5557. And that gives us negative 0.6427. And so now we can go second sine of that. So we take the sine of that answer, and let's do this in degrees because our question is given to us in degrees. So we do that in degrees, we get an answer of negative 44 degrees if we round it off. So once again, let's use our cast rule. So negative 44 would be in that quadrant there. And using cast rule, if sine is negative there, it's also negative in this one, so we'd have 44 there as well. So our angles, if we do it in the positive direction, let's do that first. We'd have 180 plus 44, which would be 224. And 360 minus 44 would be 316. So there's our 2 that we've got drawn. But we also have to go backwards. So that would be negative 44, which is the one that we just calculated. And 180 minus 44 would be negative 136. And those would be our 4 answers for that one. So really no difference when you're dealing with cosecant and secant. Just remember to do the 1 over. And other than that, use the cast rule to figure out your locations. And that's it.